you guys have the note for today, which is very, very simple, very straightforward. I think there's only like 4 or 5 slides. Yeah, there's 4 slides today. So it's not much. So again, go to weekly schedule, the little thing that said notes. We are down toward the bottom where it says covalent bonding and Lewis dot structures. So again, we haven't really done a lot with Lewis dot structures yet. So we want to start being a little bit more intentional. But Lewis dot structures are very similar to the Bohr models, and I'll draw some with you here in a couple minutes. So just remember that when there's a bond between 2 nonmetals, and again, the nonmetals are in group 4, 5, 6, 7. If there's a bond between them, they both want the electron. They both have a high electronegativity. And we talked about electronegativity, we talked about ionization energy. Electronegativity is the electron wanting, or the atom wanting electron, okay? And in that process, when they both pull on the electron, nobody's going to win. Nobody's going to lose, okay? There's not going to be a gain. There's not going to be a loss of electron. But rather, you're going to end up with a tug of war, and they're both going to end up sharing the electrons that are there and the valence electrons on the outside of each other's atom. They're going to end up sharing them in a tug of war, and that is going to create a bond between them when they undergo that tug between the electron. Okay? The cool thing about covalent compounds that ionic did not do is that ionic can start, or covalent can start forming single, double, and triple bonds. Okay, and as you can imagine, a double bond is stronger than a single bond, and a triple bond is stronger than a double bond and stronger than a single bond. And so covalent compounds can form very strong compounds because of the bonds that are single, double, and triple. Ionic compounds are actually pretty weak bonds. They dissolve, they break apart very easily. So if you think about water and salt, if I put salt in water, it dissolves, it breaks down very easily. Okay. But if you think about something like sugar, sugar is a covalent compound. It does dissolve in water, but not super easy. Like you have to warm the water up, and you guys know that. If you ever gone to a restaurant and you order tea and you had to put sugar in your tea, the sugar falls down to the bottom, right? If you warm up the water and you dissolve the sugar in it, then you can dissolve sugar in it, but it dissolves a little bit harder than the ionic salts. So we're going to be using what's called Lewis dot structures for pretty much the rest of the year on showing how the bonds are formed. Okay, the Lewis dot structures are diagrams, or drawings, okay, that show only the valence electrons. That's all we are concerned about. Okay, so we're going to use a compass system just like we did before: the up, the down, the left and right, north, east, south, west. Okay, in order to draw Lewis dot structures, and we'll always put the dots singled first. Then we will start to double them up. Okay, so we're going to do the 4 sides, top, right, bottom, left. Then we start to double up. Remember, we want to spread the electrons out as far as possible first, so they don't like each other. Then we can start to double them up. And so what we're going to do here is we're going to start, see it drawing here with aluminum. Aluminum has 3 valence electrons in group 3. We're going to put a dot on top, a dot on the right, and then a dot on bottom. Okay. We do not do 2 dots, but then a single dot, okay, because again, those electrons do not want to be next to each other in that situation. Okay. If I was going to add a 4th dot for a different atom, I would bring it over here to the left. If I was going to add a 5th dot, I'd bring it up here to the top, 6, 7, 8. And so we will circle around these atoms, making Lewis dot structures. Okay. So again, we tried one with nitrogen. Nitrogen had 5 valence electrons. Okay, so again, I'll start at the top, 1, 2 on the right, 3 on the bottom, 4 on the left, and then 5 on top for 5 valence electrons. Note that nitrogen wants 3 more electrons on the right, the bottom, and the left, okay, the east, the south, and the west. I can put 3 more electrons in that situation, okay? Now note that we have a pair up here of electrons, and we have an unpaired electron down here with the nitrogen. The paired electron is finished, is complete. We are not going to do anything to those electrons because they're done. Okay, we can't put any more electrons in there. But these unpaired electrons, those are the ones that are going to do the bonding. Okay, In an ionic bond, they would leave or gain, and a covalent bond, we're going to share. So the number of covalent bonds that element can form is equal to the number of unpaired electrons. Hopefully you guys can see it. This little stupid bar keeps messing me up. But the number of bonds that it can make is the number of unpaired electrons. So this nitrogen can make 3 bonds because it has 3 unpaired electrons. The lone pair, which is this guy up here, okay, is not shared, is not lost. Those electrons are finished. So this nitrogen can make 3 bonds with 3 unpaired electrons. And that's it. So pretty easy, right? Pretty straightforward. So let me go to kind of do a little bit of drawing here. So when we are doing our valence electron drawing, that's all we're concerned about is that last layer. And we've been kind of doing them already, but for ionics, I was asking you guys to do the Lewis dot structure. And again, I'll try to show you why we do Lewis dot structures for ionics. Again, those of you who are watching the video, I know that the whiteboard doesn't record. I'm going to do a little bit of research into this and see how I can do a little bit more recording with the whiteboard. But I apologize. If you're not on the app on your laptop, you're probably not also seeing this. Again, I encourage you to download the app on your laptop so you can see all the benefit to breakout groups, and you can do all that stuff. Okay, so download the app. Download it to your phone, download it to your iPad or laptop, whatever it is. All right, so real quick. So the Lewis dot, the reason why we did Bohr models, you guys remember, we did Bohr models. If I want to do something like sodium, Na, we said that Na had 3 rings because it's on the 3rd row. The first 2 rings are going to get 2 electrons. The second ring is going to get 8. 1, 2. Again, I'm spreading them out as far as possible. And then double up on 5, 6, 7, and 8. Sodium is in the first row in the first column on the 3rd row, so it had 1 valence electron. So if I was going to do the Lewis structure for sodium, I would just need to draw 1 valence electron. Okay, that's a lot quicker, it's a lot faster, a lot easier, right? But sodium is going to lose the electron. And so when I lose this electron, a lot of kids think, well, sodium has 0 valence electrons. There's no electrons there anymore. But that's not true, right? If I come over here and I lose this 1 valence electron, how many valence electrons does it have now? It doesn't have 1 valence electron. It doesn't have a 0 valence electron. How many valence electrons does sodium have when it loses 1? Go ahead and put it in the chat box. Yeah, it has 8. So when I lose 1 valence electron, we end up with 8 valence electrons, and 8 is octet and happy. Okay, so this sodium is now happy, it's satisfied, there's nowhere to bond. Okay, I don't have any opening to bond anywhere. So that's the benefit of a Bohr model versus a Lewis model. Okay, is that when you lose electron, the Bohr model still shows you what you have. The Lewis structure, when you lose it, it's gone. But as long as we start to understand that when I lose that electron, I don't have 0, okay? You're never gonna end up with 0 electrons. I end up with the lower ring of electrons, so 8 or 2, okay, and be an octet. All right, so on your handout for today, if you wanna go ahead and pop it up, let's go ahead and do that real quick. Let me, weekly schedule, pop up today's handout, which is over here, the assignment. Okay, so Lewis structure and bond assignment right here. Again, just like last time, we are going to, you have different options on how you can turn this in. If you want to do it electronically, you can do it electronically. If you want to do it on paper, which I recommend, you can take a picture of it. Okay. When we start coming back to school, we're gonna start having a lot more paper handouts so that you can actually draw stuff. It'll be a lot easier. If you're virtual, no worries. You'll just have to take a picture of it and submit it instead. So I am asking you to draw today, okay? So how you draw is going to kind of be up to you. I personally, I would just draw on a piece of paper and then put your picture down here. That's what I would do. However, you can go to Insert, Drawing, click on New Drawing, and then you can try to draw what it's going to look like. Okay, especially if you go to like Scribble, Lithium, and Lithium is going to have one dot, right? I might even change my color here. Lithium is going to have one valence electron. Again, note that that's not a very fun drawing for me to do, but hey, it works, right? I might get rid of this little dot here. Okay. So you could draw it on your laptop if you wanted to draw it. And again, it's not super fun to do that. You could also like maybe edit. I hope you can see everything I'm doing here. Can you guys see me drawing right now?
Yes.
Okay, you guys can see your drawing tool? Okay. Maybe instead of doing that, I can do a circle. And I can change the color of the circle. Okay, so there's my dot. I can do something like that. Okay. Now, some of you are really creative, and some of you guys know how to use other drawing tools. So if you want to do a different drawing tool, you can do a different drawing tool if you want. There's one, what was it? I forget. No, but what was the one that you did? Was it Lucidchart or something? Noah does really good drawing. I think it was Nova. Somebody doing like Lucidchart drawings or something like that. But if you guys want to draw it on your laptop, you can draw it on your laptop, or you could draw it on your worksheet, and you guys just do that. Whiteboard. All right, well, I'll have to look at that later. Okay, that's interesting. Okay, so on that handout, which is right here, so that's Lewis dot structure. Remember, it is in the first column, so it had one valence electron. For number of valence electron, pretty easy, one. For the Lewis dot, however many dots you draw, that's number of valence electron. So how many covalent bonds can it form? How many covalent bonds can lithium form?
One.
It's a trick question. Can lithium form covalence bonds? Lithium is a metal, right? So 0 covalent bonds. Lithium is a metal, okay? All right, so you gotta be careful. Covalent bonds are only between elements in 4, 5, 6, and 7, those columns, those non-metal. Okay, so it's a little bit of a trick question. So lithium cannot form covalent bond, it forms ionic bonds, right? All right, I know that's a little tricky, but just be careful. I want to make sure you understand that covalents are between non-metals only. Okay, metal cannot form covalent compound. All right, you have, I don't know, how many is that, 7? You have 7 practice problems that you guys could work on. Again, watch out for the trickiness between covalent and ionic metals and non-metals. So keep an eye on that. And again, I want you to practice drawing today. Today's assignment should not take you very long. Some of you have already finished it. Should not take you very long. It's a very short, sweet, simple assignment. But going into the future, we really do need to make sure we're drawing correctly. And so I am going to be looking at your drawing. I'm going to be making sure you know how to do this. Okay. If you don't know how to do this, it's going to it's going to really mess up your future. I mean, literally for the rest of the year of chemistry. Being able to understand who's going to bond, who's not going to bond, why they're going to bond, how are they going to bond. We really need to be able to show our drawing so that we can make predictions, so we can figure out what's going to happen. Because that's really, it's going to be the rest of the year, figuring out what happened to these guys. Okay. And especially when we start getting back in the classroom, we start doing reactions, start doing labs, we can actually start seeing what's going to happen to these atoms, these ions, these covalent bonds. Okay, that's it for me. You guys work on your handout for today. Again, this should be done right now. This should not be something that we're blowing off. We should get this finished. We should get this turned in. Again, the easiest thing for you might be to draw on a piece of paper and then submit that piece of paper. Just put it down here at the bottom of the handout. Okay, take a picture of your notebook, put it at the bottom of the handout, and then turn it in the handout. Okay, so I'll leave that up to you on how you want to draw it, but make sure your drawings are obvious. And the other thing too, and I'll be quiet in just a second. The other thing too is that when you're doing drawing, and I'll show you a quick example here. When you're doing a drawing, be very specific about what is an electron and what is not an electron. Okay, so again, hopefully my board pops up here. So for example, if I'm going to do lithium and I do something like this, all right, is that an electron right here? Okay, like is this thing an electron? Is that an electron? What is it? Okay, try to be very specific about it. Okay, so again, if I do lithium, I might do something like this, but again, don't have any stray marks over there. Like, what is this thing? Okay. Don't have any stray marks on your drawing. Try to be super obvious. Yes, you're just drawing the valence electron. That's all you're drawing for today. Friday, you're gonna start doing compounds on Friday. Yep. Yeah, so you're drawing one atom today. Pretty simple. So again, so if I do something like carbon had 4 valence electrons, and I start like I don't know what that is. Okay, I don't know what you're drawing. Okay, just make sure that is super obvious, and make sure there's no stray marks on your, make sure there's no weird marks over there. Like, well, what's that thing? Okay, so just be really obvious about it. Again, when we're drawing, make sure you are doing single first, then you double up, because if you do this, if you draw something like that, that told me that you can't make any bonds because they're all paired up. All right, I keep clicking on my board. They're all paired up, and that's not correct. Okay, so I can make 4 bonds. 1, 2, 3, 4. Okay, that's it for me. I already gave you a bunch of answers, by the way. Yes and no drawing. So, all right. If you guys have any questions, make sure you reach out. And then I'm hoping you're done very quickly today, and I'm hoping you turn in other missing work. Okay.